So if we represent this whole box as U, our entire sample space, and this little bubble as A, then the rest of this stuff should be A prime, okay? So maybe our set of values is 1, 2, 3, 4, 5, 6, 7 down here. Let's let A be 2, 4, and 6. So A is a subset of our sample space. I guess we could call our sample space S instead of U, since that's what they use in the example. I'm sorry. Okay. So if the entire set S consists of these numbers and A is 2, 4, 6, A prime has to be the rest of them. So Jordan, can you tell me what to fill in the rest of the box?
I honestly don't know.
Okay,
oh, wait,
so
it's 1, 2, or 1, 3, 5, 7.
Wait, I'm asking Jordan. So S is all of these numbers. A is just these 3, and A prime is going to be the rest of them. So what's the rest of the numbers minus these numbers? So these, remove those.
1, 3, 5, and 7.
There you go. Okay, so A prime is going to be the set 1, 3, 5, 7. Okay, what questions do you guys have about that? Okay, this P here means the probability of. Okay, so what we're saying is that the probability of A happening plus the probability of A complement happening is going to be 1, which is the entire probability. There's 100% chance of either of those happening. Okay, so we're going to fill in these A and A prime values. Okay, so let's see. Brianna, we're given that our sample space is Roy G. Biv. If A complement is OGB, what should A be?
R Y G I V.
G is over here.
Oh,
G is in the prime.
so just I and V.
Yeah, I and V. V as in violin. Very good. Now, Brianna, can you also help me out? The probability of A is going to be the number of elements in this set divided by the total number of elements. So what's the probability of A going to be?
Wait, can you repeat that?
So the probability of A will just be the number of elements in this set. So how many elements are in this set?
4.
Yeah. Divided by the total number of elements. So what was the total number of elements?
7.
Yes. So how do I get my probability?
It would just be 4/7, right?
Perfect. Yes. And then what must be the probability of the complement?
3/7.
3/7. Yeah, perfect. Very good. Excellent. All right, Izzy, can you help me out with the next one?
Yes.
All right. So what should A prime be?
G, and then 5 Y's.
Yeah.
And 1 B.
Okay. And what are my probabilities for each piece?
A is 4/11, and A prime is 7/11.
Good. Perfect. We're already running low on time, so I'm going to go ahead and do the next one. So A is 25 and 16, A prime is 31, 1, 7, 4, 11, which means that my sample space is just going to include all of those values. So 1, 4, 7, 11, 16, 25, and 31. Okay. Our probability of A happening is only 2 out of 7. And our probability of the complement happening is going to be 5 out of 7. Okay, what questions do you guys have about filling in that table? Okay, so now we're going to talk about intersections and unions. So the intersection of two sets is notated by A and then this cap and a B. If you are doing probability on your IA and you need to type this symbol, it's / cap and then do a space. Okay, and this is going to represent the piece in the middle. So we have A, we have B, and the step in the middle is the intersection. Okay, in words, the intersection means the set of all elements common to both sets. Also, I've already posted these solutions, so if you need to go back and look at something we've already done, feel free to pull those up. And in set notation, so this is set notation down here. Okay, this is the set such of X values, just X represents any given value. The colon represents the words such that X is in A and X is in B. Okay, so over here to the side in the little thought bubble, this 2 epsilon A reads as 2 is an element of the set A. Okay, so down here, this reads X is an element of the set A and X is an element of the set B. And this little colon means such that. It also might be written as like a little line, a vertical line. Either of those is sufficient. Okay, questions about the intersection? Okay, the union is written as A, U, B, and that U, if you are typing it into the equation editor on Word, is \cup. Okay, the union of A and B is going to include every single bit of both of these. Okay, we're combining every piece. So in words, the union means the set of all elements belonging to A or B or both. Okay, so it can be in just A, it can be in just B, or it can be in both of them. In set notation, it's X's such that X is in A or X is in B. So the and here requires that both must be true. The or means that either one could be true. What questions do you have? Okay. If A intersect B is the null set, so this is called the null set, and I don't think that that's actually written on the solutions. that I posted. That's NULL set. Like if you're playing spades, then no, like you go null or whatever. What would the Venn diagram look like? This means that there is no intersection. So I have to have a circle with A over here, a circle with B over here. And this is called disjoint. Okay, those two events have nothing to do with each other. So we call A and B mutually exclusive. Okay. So an example, maybe, let's see, let me think of an example. Two things that are disjoint. So like rolling a dice and flipping a coin have no intersection. There's nothing that's going to correspond with one another. Okay, you get numbers here, you get heads or tails here. There's nothing in this set that's going to intersect with this set. Or if you're thinking of like maybe fruit, like where a nectarine is a cross between like a peach and something else, apples and oranges have like no intersection. There's nothing that crosses between them. I don't know. Okay, what questions do you guys have about the disjoint concept? Do you guys need a minute to copy that down? Can I start the examples on the back? Where are y'all at?
I'm good with the notes.
Okay, so we're gonna go ahead and flip. If you are not done, again, you can pull this up on Canvas and look at it while we're doing examples. And then the examples should be there too, so you can go through those. So I'm going to do all the examples in the left-hand column, and you can complete all the you-dos and any examples we don't get to. All the solutions are in Canvas. So in example 1, it says the Venn diagram below represents a sample space of all children in a class. Each dot represents a student. The event A shows all the students with blue eyes. Determine the probability that a randomly selected child A has blue eyes and B does not have blue eyes. So there are 10 dots here and there are 17 dots here. Okay, so for part A, our probability should be 10 out of 27. For B, our probability should be 17 out of 27. What questions do you have? Hopefully that one's pretty straightforward. In example 2, it says on separate Venn diagrams using two events A and B that intersect. So we know that they intersect, so I'm going to draw an A and a B for each one, and they have to intersect. Okay. Part A says shade the red region representing in A, but not in B. Okay, so it's in A. We know it has to be in this circle, but it cannot be in B at all. So I cannot shade the intersection. Okay, so I have that stuff there. And in B, it says neither A or B. So I have to shade in everything around A and B. I cannot shade the intersection. I cannot shade in B. All that stuff. What questions do you guys have about that? Okay. In example 3, it says if the Venn diagram below illustrates the number of people in a sporting club who play tennis